This question, consider the current carrying loop form of radial lines and segments of circle whose centers are at point P. We have to find the magnitude and direction of the magnetic field at P for A as 10 centimeter and B as 20 centimeter, and the current is 2 ampere. Okay. So there are four segments from which we have to take care of the magnetic field. One is this arc, one is this straight wire, one is another arc, and then we have this straight wire and this straight wire. So there are one, two, three, four, five. Fortunately, because of these straight wires, the magnetic field will be zero. And why is that? Because the magnetic field, because of a current carrying wire, is mu naught I over 2 pi times its perpendicular distance. So basically, the magnetic field, uh, because the current carrying wire generates a magnetic field which is concentric. So for a point which actually lies on this wire, for example, like here or here, there is no magnetic field, right? Because its perpendicular distance is there's no perpendicular distance, right? So it's there's no basically no magnetic field which is generated on the same wire. And if we notice carefully, this point is on this wire only, right? If we extend this wire, all these three wires, this point lies on that wire when extended. So there is no magnetic field because of the wire. So that's a relief. The only magnetic field will be because of the two circular arcs. The direction will be given by right hand rule. So we take our right hand and we take our right hand and we curl our fingers. We take our right hand and we curl our fingers towards the current. So the thumb will point towards the direction of the magnetic field. So because of the smaller arc, that will point out of the page, because of the bigger arc, that will point into the page. Okay. So the magnetic field, because of the smaller arc, that is with the radius of A, that will be mu naught I over 2 times A. But mind it, this is because of the complete circle. And so because of an arc of angle theta, that's going to be theta over 2 pi. Theta over 2 pi. And of course, this is pointing out of the page. And likewise, magnetic field because of B is going to be mu naught I over 2 times B theta over 2 pi once again, which is into the page. Since B is greater than A, so denominator is more. So definitely B because of the outer one will be less than B because of the inner one. So the net magnetic field is going to be A minus B, because they are in opposite directions, right? And A is a higher magnitude. So that will be mu naught I over 2A theta over 2 pi minus mu naught I over 2B theta over 2 pi as well. So we can take mu naught I theta over 4 pi common. So we are left with 1 over A minus 1 over B. Mu naught is 4 pi times 10 raised to minus 7. Current is, I think, given in the question, 2 ampere. Theta is not given in the question. Let's keep it theta. 4 pi remains 4 pi. I just want to confirm the current once again. That's 2. Okay. And A and B are 10 and 20. So this will be, but mind it, this is in centimeters. So 10 centimeters, 0.1 meter, and 20 centimeters, 0.2 meters. So 4 pi and 4 pi is cancelled. So we are left with 2 theta times 10 raised to minus 7. 1 over 0.1 is 10 and 1 over 0.2 is 5. So 10 minus 5 is 5, 5 times 2 is 10. So that's 10 theta times 10 raised to minus 7, which is nothing but 10 raised to minus 6 times theta. Since the value of theta is not given, so we'll just keep it like this only. Let's see if there is any other way we can actually find out the value of theta. So theta is not given, hence we'll leave the answer just like this, where if at all we have to put theta, then mind it, theta should be plugged in terms of radians. This is the final answer in Tesla. Thank you.